Okay. Well, I think we'll start now, and hopefully some people who will join us in the next few minutes after we've gone through the introductory elements of this webinar. So, welcome. So this is the WCRP webinar on green shoots from burning embers, moving from environmental crisis towards sustainable solutions. So this is the second webinar in a series for the Safe Landing Pathways discussion group of WCRP. So to give you a bit of an introduction, I'm going to hand you straight over to Kevin Reid, and then we'll start the discussion in earnest after that. Thank you, Kevin.
All right. Please. Thank you, Peter. So yeah, as Peter mentioned, this is one of our webinars here in our Safe Landing Climates webinar discussion series. And so this is part of the Safe Landing Climates Lighthouse within the World Climate Research Program that really focuses on exploring different routes to safe landing spaces for both human and natural systems. A lot of the work starts to explore different types of pathways to avoid dangerous climate change, while also at the same time thinking about how the science and the discussions that we have can contribute to sustainable development goals. The Safe Landing Climates Lighthouse is really organized into 5 main working groups, spanning everywhere from high-risk events to sea level rise to water resources, as well as the carbon cycle. But this working group is focused on safe landing pathways. And so a lot of what we're doing through these discussion series, as well as some of our own internal discussions amongst the working group, is we focus on trying to think about what climate trajectories and destinations are actually safe, and which ones are unsafe and why. This theme is really focused on putting together interdisciplinary communities and sectors to determine pathways and landings that help us preserve habitability, well-being, and food security in the future. And so what we're kind of doing at this point in the phase of the working group is it's really having an exploration about what are the current state-of-the-art topics out there on these different types of aspects related to a pretty broad area, as well as having discussions around specific areas like we're going to today. So, our expected outcomes of this working group are really focused on an exploration then of these diverse approaches for future scenarios that can be more relevant in some cases outside the typical climate science sphere, to help dialogue on a variety of understanding and constraining of individual risks, as well as assigning overall levels of risk for these potential future pathways, and really integrating Safe Landing Climate Lighthouse as a whole in the context of adaptation and resilience strategies across the world. And so how do we have those type of foster that dialogue between communities and understanding different ecosystems in order to really meet these ultimate goals? And so, as I mentioned, this is a working group within the Safe Landing Climates Lighthouse that's co-chaired by myself, as well as Neil Harris. But we're made up of almost 10 other individuals from around the world that are also helping us with this effort. So I'm going to turn it back to Peter to kind of kick us off on our discussion for today.
Great. Thank you, Kevin. So we have 3 great speakers within this event. So we start with Robert Watson, and we've got Nick Jessup and Alma Arneath. And they're going to talk roughly for 20 minutes each, and then we're going to have roughly half an hour for a panel discussion. If you have questions, we'll take them at the end. You can add them through the Q&A element in Zoom, and then we'll address those questions in that panel discussion phase. So to start, our first speaker is Robert Watson. I'm sure he'll be known to most of you. He was former chair of IPCC and IPBES. A chemist by training, he's an expert in atmospheric science, contributed his expertise to NASA, the White House, World Bank, UK government, and has had many leadership roles at national, international, and intergovernmental level. Knighted in 2012, is currently an emeritus professor at the Tyndall Centre for Climate Change Research, even at the University of East Anglia. So I will pass it over to you, Bob. Thank you.
Thank you, Peter. What I'd like to do today is quickly look at the issue of climate change, but in a broader context. If I could have the first slide, please. The key message that I want to get across is that climate change is next slide, please. Climate change is just one of 4 major global, next slide, please. Climate change is only one of 4 global environmental issues that threaten human well-being. The others are loss of biodiversity, land degradation, air, water, and land pollution. The key issue here is they all interact with each other. Climate change affects land, it affects biodiversity. Changes in land, biodiversity affect climate change, and they all affect human well-being. So the key message is we cannot look at any of these 4 issues in isolation. They must all be addressed together, along with some of the key development challenges as embedded in the Sustainable Development Goals. The next slide basically says we can no longer think of any of these 4 environmental issues as just environmental issues. They're economic issues, they're development issues, security issues, social, moral, and ethical issues. And so if we do want to eliminate poverty and hunger, have access to clean water and energy, a healthy, equitable, secure quality of life for everybody, we must address all of these together. We need to understand the complexity of the system. The next slide simply shows effectively the so-called wedding cake, and that really simply says if we don't deal in the bottom level with climate change and loss of biodiversity, we will undermine food and water security. We will undermine efforts to make our cities and our communities more sustainable, and ultimately will undermine human well-being. We will not be able to eliminate poverty. We will not be able to have a more equitable world. We will not be able to have good economic development and peace. And clearly, if we don't deal with these so-called environmental issues, they all threaten human health. The next slide simply says some of the goals we need to aim for. We need to mitigate climate change, adapt to climate change, conserve terrestrial water, fresh water and marine ecosystem. We need to restore those systems that are degraded. Clearly, we must reduce air, land and water pollution, and we need land degradation neutrality. There are international goals for all of these issues, and we are failing to meet any of them, and we're failing badly. Equally, we need to focus on the SDGs. They're intertwined with these so-called environmental issues, in particular, human health and well-being, food, water security, equitable societies. The next slide certainly says, well, how do we address this? Well, fundamentally, it doesn't matter which of the 4 environmental issues we deal with. Really, we have to focus on the production and use of energy and the production and consumption of food. From a climate perspective, about 70% of all greenhouse gas emissions come from the energy system, and about 30% come from the agricultural food system. Within the food system, the livestock system is particularly important. If you include the supply chain of livestock, it's 60% of all food emissions. Therefore, we need a complete transformation of the energy, food, economic, and financing systems. And I'll come to a bit more of that in a minute. The next slide just simply shows what's happened since 1990 with greenhouse gas emissions. And as you can see, carbon dioxide is the dominant gas, both fossil fuels, CO2, and land use CO2. But we also have to worry about methane, nitrous oxide, clearly key contributors, especially from the agricultural system. We've already seen the world warm by more than 1 degree Celsius over the last century. Sea level rise is accelerating. We're seeing more frequent and intense extreme events, and we're seeing major losses of Arctic and Antarctic sea ice. And all of these things are threatening people and nature. The next slide then talks about land use. We've already converted 3/4 of our land from natural system. 1/4 of that land has been radically transformed, and all of the projections suggest that by 2050, less than 10% of the ice-free land on Earth will be in anywhere close to a near natural state. And as I've already said, 25–30% of greenhouse gases come from land use change. And this slide simply shows you on the right-hand side how we're currently using our land, how we've transformed it. The next slide moves on to the sort of the burning embers. All I want to do with this slide is not talk in detail, but you can effectively see it. It's a beautiful illustration from IPCC of what is the risk to different systems at different levels of changes in temperature. So in the top, you have what's the threat to unique and threatened species, extreme weather events, distribution of impacts, etc. Lower down in the next level, what's the implications for biodiversity loss, structural changes in ecosystems, tree mortality, terrestrial systems. To the right of that, we have the oceanic systems, the most sensitive being warm water corals. In all of these, you see that once you get we're already at 1.2 degrees Celsius warming. By the time you get to 1.5, in many of these systems, we're already in the medium to start to be the high risk. And at 2 degrees Celsius and above, many of the systems move into high risk. And so clearly, we have a major job to try and limit human-induced climate change. The next slide. This actually shows you where are we. Well, this shows you emissions from 2010 to 2020 and projections to 2030. If we want to be on a pathway to 1.5 degrees Celsius, we need to reduce current emissions by 45 or 50% by 2030. If we're willing to live with a 2-degree target, we still have to reduce emissions by about 25% relative to today by 2030. All the current projections suggest that with the current pledges from governments, which are totally inadequate, we are likely to be comparable or even as much as 15 to 20% higher emissions in 2030 than we are effectively in 1990. Clearly, we're going in the wrong direction. The next slide simply talks about this, and what it says is, yes, the Paris Agreement is an incredibly important step to limit human-induced climate change, but with the current pledges, we're on a pathway of 2.5 to 3, not 1.5 to 2. We're likely to pass 2 degrees Celsius between 2050 and 2060. We're likely to pass the 1.5 target in the early 2030s. So unless we get cost-effective negative carbon emission technology, of which I'm skeptical, the Paris targets are unachievable. We're going to need to live in a world between 2 and 3 degrees Celsius if indeed the pledges are met. I actually believe focusing on net zero by 2050 is dangerous. It's taken the effort away of governments of what is really needed, and that is reduced emissions between now and 2030. We do need net zero by 2050, and that's what all governments are focused on. The key issue is what we do in the next 5 to 10 years. The next slide, please. It's quite clear that we're capable of moving to a sustainable future. Our human knowledge, our ingenuity, our technology, we can secure a sustainable future, but it will involve a fundamental change in our technological, economic, and social organization of society. We have to think our world views of a vision, our norms, our values, and our governance structures. We need to have major shifts in investment and regulation, and we have to overcome inertia and opposition from vested interests that love the status quo. And so the challenge is we need to both mitigate adverse outcomes, and we've clearly got to adapt to inevitable changes. The next slide clearly says we need to transform our economic financial systems and our productive systems. We need to eliminate or repurpose harmful subsidies. We need to embrace a circular economy, internalize externalities, and include the value of natural capital in decision making. And the question is, how do we do this in a way that is both politically and socially acceptable. We can then actually use the money that we save here in these subsidies for environmentally sustainable technologies and policies. Next slide. So there are 5 levers that we're currently thinking about in Geo7, which I co-chair, of how to stimulate transformation, how to stimulate action: economic and financing, institutional and political, social and cultural, science, technology, innovation and knowledge, and capabilities. I've already touched upon the economic and financing, such as subsidies, internalization of externalities, institutional and political, strengthen regulations on the energy and food sector to control or break up monopolistic power, change international trade regulations, social and cultural, influence social norms through providing information, science and technology, develop technologies for sustainable and climate resilient energy and food systems, capability, increase public awareness. The next slide, and I have to thank Peter Alexander for this. He designed this slide. So if you're only looking at how do you transform the food system, on the right-hand side, we have those levers. In particular, what are the issues within economic and financing that relate to food, or on social and cultural relate to food? So you have the 5 levers, and we have sub-levers. Then say, what are the solutions we're aiming for? More sustainable consumption, improve production, create a circular food system. How do you have novel food production processes, and how do you restructure the global food system? So what is the combination of levers that can be used to meet every one of those solutions? Then you say, what combination of solutions meet our final goals, human health and well-being? How can we actually have an agricultural system that is sustainable with respect to terrestrial and marine ecosystems, no loss of biodiversity? How do we have a food and agricultural system where there is no impact on climate? So climate mitigation. How can it be a more equitable system, and how can it be resilient to shock? So we're using these levers and sets of solutions for transformation of the economic and finance system, the energy system, the waste system, and environmental system. And then what we're asking in the next slide, and I've just about finished, is what are the role of all the actors? We need to speak to every actor. The role of government, international organizations, financial organizations, NGOs, the private sector, the public and scientific organizations. We need to make sure our documents talk to every one of these stakeholders. And the last slide just suggests a few roles for government. They need to lead change through cross-sectoral policies, legislation, enforcement, monitoring. They need to lead the scale up to accelerate action for all 4 of these environmental issues. They must take the lead in transforming economic and financing systems, and they need to take the lead in helping to transform our food, energy, and production systems. So fundamentally, we have a similar approach for NGOs, for international organizations, private sector, etc., which I won't go into. The key point is all of these issues are interrelated. And so the key messages are, look at all 4 environmental issues together, recognize they're intertwined with all of the SDGs, and therefore we have to have very holistic systems for solutions. But it's doable. But there are vested interests that are trying to stop it. And at the moment, we are not on the way to a sustainable future. Thank you.
Thanks, Bob. That's great. Maybe not entirely encouraging, but very interesting. Yeah. So, I mean, obviously, you talked there a lot about the need to transform the financial system. So, I think the next speaker will be talking much more specifically about the financial system. So I'd like to welcome Nick Jessup to talk. So Dr. Nick Jessup, he's a financial economist and scenario modeling expert. He currently works at Moody Analytics and leads a team of economists and quant analysts working on climate risk management solutions. He's an astronomer and astrophysicist by training and works on climate risk modeling and financial valuations to help organizations understand risk and uncertainties associated with climate change. His recent work has included developing tools which are being used by institutional investors to assess their climate change risk exposure. So thanks, Nick. Can I pass it over to you?
Sure, yeah, and I'm going to share my own slides if I can. Let me know. Hopefully I'm going to go into slideshow. Can you all see full screen slides?
Yep, that's looking good.
Okay, so yeah, I'm going to follow on, I think, on some of the themes that Robert was talking about, focusing more on finance and economics. And I guess I'm conscious that the audience is maybe not that familiar with what's been going on in finance over the last decade or so, but climate risk, as has been kind of labeled in finance, has become a really big focus ever since the Paris Agreement. And this slide presents a timeline where we're kind of showing you what's kind of happened. So about 2015, the sort of financial system started looking at this. The task force for climate-related disclosures was set up, and ever since then there's been just a progress of kind of change going on. So in 2017, Network for Greening the Financial System was set up. The climate system in 2018 started doing stress tests, climate stress tests, first in the Netherlands and then Bank of England, and going into sort of COP 26, the Glasgow Financial Alliance was set up, which was really focused on how finance companies might align with net zero and commit to net zero. Now, if I'm being honest, there has been a little bit of backlash in the last year or two, given some of the things that have happened in the economic space, and in particular with the energy crisis, the increase in inflation. There has been some focus, and in particular in the US, there's some pushback. But one of the things that's characterized is growing use of climate scenarios in finance, and one of the reasons why people are doing this is it's very similar to existing sort of stress testing and scenario testing that finance companies do all the time. The idea is to try to understand possible future states of the world and assess what the impacts will be on businesses, and also the impacts of businesses on the broader economy and the ecological and environmental system. And one of the things that's happened in finance is a set of specific scenarios have been pulled together by a group called the Network for Greening the Financial System, based on many of the scenarios that you guys will be very familiar with. So this is the one slide where I really kind of focus a little bit on physical climate modeling, which I understand a lot of people in the audience might be their focus. So, so what the finance world is trying to do is use the kind of standard climate models and scenarios that have been produced in academia. So, for example, some groups do use the physical climate scenarios and models that have been put into CMIT 5 and CMIT 6. They tend to be used for specific applications, in particular looking at things like insurance underwriting. More generally, people have been looking at emissions pathways and what I call integrated assessment models, which are basically energy system models. And then those are then used to convert into climate and temperature outputs using things like the GIST4 model, MAGIC-C. And a big focus is on the uncertainty in the climate, the evolution of the climate. So we do kind of recognize that there are various different feedback impacts that are very important and do mean that we don't necessarily know exactly what pathway we're on, even if we know our emissions or greenhouse gas concentrations. And what we try to then do with these models is, this is a kind of overview of what we're trying to do. you need to try to understand climate pathways better, then start to interpret the economic implications, then convert that into financial stresses or financial implications, and then finally sort of expand the variables into a broader set of exposures that financial companies and investors might have. And typically these are then input into what we call risk management systems or strategic asset allocation frameworks to help inform how capital and how investments are being made. So in the next 3 or 4 slides, I'm going to go into a bit more detail on I guess what's step 2, 3, and 4 here. So what do we mean by, or how do we think about the economic implications, financial implications? So, and this is one way of thinking about it as a macroeconomist. So what you look at when you're looking at 2 pathways, the big difference is in the level of investment that you need to we're going to need to make as a society. So on the right-hand side here, we're showing the costs that are associated or would be associated or we expect to arise as a result of a hothouse scenario, or in particular here, what we're looking at is nationally determined contributions. And the scale here is in billions of dollars. So what we see here is that the costs, we're using a terminology which is, I guess, specific maybe to financial and economic modeling, where we talk about physical damages. So these are costs that arise because we have to deal with the physical changing climate. So things like adaptation costs, resilience costs, and kind of the repair costs, responding to climate damages. And these potentially climb in this scenario to over 20, 30, 40 trillion dollars per year globally. On the left-hand side, we're showing what happens in an orderly transition. In an orderly transition, there's more investment needed sooner. The investments are split across a range of different outputs. So we have to potentially think about abating emissions. So that is investments in net zero or low carbon technologies. We have to think about introducing carbon prices, and we also have to think about how our productivity will change. So there's what we call a sort of endogenous GDP or productivity impact we have to worry about. And the thing to realize in both of these situations, there is massive change in the economic system, because one way to put these numbers in perspective is that already at the moment we spend about a quarter of our economic output on investments, and that means about $20 trillion a year at the moment. So what we're seeing in both of these pathways is that climate, whether it's dealing with the physical changes or whether it's dealing with the demands of transitioning towards a net zero economy, will come to dominate those investments, the level of investments that we're making at the moment. And then to understand what this means for financial systems, potentially, if we think of those investments as being opportunity costs, what it means is that there will be a drag in long-term investments. Here we're comparing expected returns, cumulative returns in UK equities, the FTSE all-share index, if you like. And what we're seeing is that under these different pathways, we do expect to see a drag on returns, long-term returns, as we look at these scenarios. And typically what we're seeing is the transition scenarios will be hit earlier, but over time, as we transition towards a net zero economy, you should end up in a situation where those scenarios actually start to produce positive returns in your investments over the longer term. And one of the things we do is that we do impact analysis assessment. So here's a specific example of doing this. So this is an exercise I did myself where I looked at pensions investments, and in particular, we were looking at living wage pensioners or workers in the UK. So these are low wage workers in the UK, typically, people like shop assistants, maybe only earning 10, 12 pounds an hour. They have been enrolled in what is known as an auto-enrollment process, where they are investing a certain amount of their wages, hard-earned wages, every week. And over time, they're expected to build up a pension pot that will supplement the state pension. And what we kind of see here is that when we compare different pathways, and also different model assumptions for different pathways. So here we're looking at different energy system models. There can be a significant impact on the outcomes. Here I've looked at different generations. So there's a generational aspect to this, which is that Generation Z, the youngest workers, are typically the ones that we expect to get hardest hit, particularly by current policy scenarios. Now, a lot of this work, one of the issues, I guess, criticisms, a lot of this work in finance is very long term. You know, where with retirement case studies, that is appropriate, but there has been a lot of talk about, well, could we, or could this lead to shorter term impacts? And a lot of focus on what we might call sort of shorter term scenarios. And because financial markets are forward looking, it turns out there are potentially mechanisms by which this could happen. And in particular, there's this idea of capitalizing changes in expectations. So the markets, if they price future changes, that can potentially pull the impact forwards through time, and markets may well overreact and then correct to the changes that we're seeing. So this is what we would call or label a Minsky moment in economics. So this is the idea that longer term, these very long-term changes that we're thinking about in the different pathways could potentially produce a much shorter term impact if markets fundamentally change their expectations for future outcomes. And that is a big if, which is one of the reasons why climate risk and all of this analysis looking at focusing on the downside of climate for financial markets is kind of being somewhat questioned at the moment in finance. So people are like, well, you know, is it really going to play out this way, or is it not? It's a very fair question to ask. So what then are the alternatives? Well, before we go into those and before we start focusing a bit more on alternative ways of thinking about the problem, I think it's worth putting this climate risk trade-off into context, because underlying a lot of the analysis we're doing is very uncertain exposures, economic exposures. And I'm showing this on the left-hand side. This is a takeout from the IPCC report where they looked at economic impacts. Huge range of potential estimates for impacts that range anywhere between no impact and the economy will halve in size if we were to hit, say, 4 degrees C. If you take the middle of the path, as you might be tempted to do, then what you find is that often the marginal trade-off in long-term financial wealth is pretty small. And here on the top right, I'm showing an example from a recent paper by Nordhaus. What he's sort of saying is if you look at whether or not we will be more or less wealthy comparing different scenarios, actually the financial trade-off is pretty small. The optimization, if you like, the curve, the cost-benefit optimization curve for financial outcomes is actually pretty flat, very flat, which means that you've got a lot of scope to choose second-best solutions. And a lot of what the finance work does is ignores, obviously, the very significant ecological and socio-economic costs that have been focused on by people like the IPCC in their latest AR6 report, so the representative key risks. So just to say one more thing about this, it might be a bit misleading because on the one hand, I said 4 or 5 slides ago, this change is huge. It is huge in terms of the switch in where we have to put our investments, where we allocate capital is huge. But if you look at where we potentially end up, we're in a very different world, but in pure financial terms, at least if you believe the middle of the road damages here, the trade-off is there for us to make and to choose on. So that then makes me think, well, what should we be focusing on? And one way that we could change the focus away from climate risk is to start focusing more on what needs to be done. So one way we could do this here, I've labeled this the stairway to net zero. These are what are known as marginal abatement cost curves. They tell you something about how we have to decarbonize the economy and what price or what cost. It's important to realize that subsidies and policies will ultimately drive the outcome. So this is a paper by the IMF published a couple of months ago where they're showing that the overall subsidies in fossil fuels are high. A lot of those subsidies are implicit, so it's because we're not charging for damages and externalities. If we deal with those, then potentially we can change the pathways that we're on to pathways where we are genuinely cutting emissions over the next 5 to 7 years. And that is an area where finance is beginning to focus more. So, and one example of that is what we might call temperature alignment or net zero alignment. So where we look at individual companies or we look at individual investment portfolios, and we try to understand to what extent the emissions are and the emissions plans are aligned with future outcomes. So very quick set of conclusions. I think there's clear alignment similarities in the approach that finance has been taking on this. There's been a strong focus on downsides, what finance we call climate risks. For me, what is more interesting and what would be more potentially useful would be to turn and start looking at what we should be doing, because the economics and the financials are fundamentally very uncertain. And one example of this is the sort of growing focus on alignment metrics for firm level and portfolio level. I think on the last point, it's important to realise that at the end of the day, it's the subsidies which will drive the level of transition and the speed of transition. Yeah.
Thanks, Nick. That was extremely interesting, as ever, to hear from you. I think there's lots to pick up on in the discussion there about how we do align some of these sort of outcomes that are non-financial within that financial system and subsidy system. But we'll probably pick up on that topic in the panel discussion. But yeah, that was great. So we have now our last, third and final speaker, which is Alma Arneith. So Alma is a professor at KIT, the Karlsruhe Institute of Technology in Germany. She's a group leader of the Institute of Meteorology, Climate and Environmental Research, and based in the very beautiful Garmisch-Partenkirchen. Her research is focused on global scale modeling of the interaction between climate change, land use change, and terrestrial ecosystems. She was a coordinating lead author for the IPBES Global Assessment and the IPCC Special Report on Land and Climate Change. Has been a lead author on a number of other IPBES and IPCC assessments as well. And last year, she also won the Gottfried Wilhelm Leibniz Prize in Germany. So I'm going to turn it over to you, Almut. Thank you.
Thanks, Peter. Okay, you should be able to see my slides now, I guess. Cool.
Yes,
yeah, so I'm actually going to talk about the green shoots now, which is sort of, relates actually to a paper that me and a number of co-authors published earlier this year. And I'm going to talk very much about biodiversity, actually, not so much about climate change. And just to remind ourselves a little bit about the conventional biological diversity, which is sort of a parallel convention to one on climate change, came into force in 1993 with three main objectives: the conservation of biological diversity, of course, the sustainable use of the components of biological diversity, and the fair and equitable sharing of the benefits arising from the use of biological resources. Amongst others, the CBD had the so-called IT targets to be reached by 2020, but like many of other environmental and sustainable targets, like Bob had already alluded to that, none of those 20 targets by 2020 were actually reached. 4 of them were partially reached, but in 5 out of 20 things actually got worse. So in the CBD, we are now in the sort of post-Aichi time, with the Kunming-Montreal Biodiversity Framework agreed late last year, with the statement that by 2050, biodiversity is valued, conserved, restored, and widely used. In order to achieve this by 2030, urgent action will have been taken to halt and reverse biodiversity loss. Rather than 20 Aichi targets, there's now 23 targets formulated in that framework. And I'm going to focus a little bit on target number 3, the so-called 30 by 30 target, which means that by 2030, at least 30% of terrestrial inland water and coastal and marine areas should be effectively conserved and managed through protected areas and other effective area-based conservation measures. The whole target is actually much longer. Have a look at it if you wanted to read it, but this is the essence of the what's on the agenda. Now, stepping back a little bit and moving to, the nature green shoots, which we started to develop to look into solutions that helps us to get out of dangerous interferences in socio-ecological systems. And the whole thinking really started with the burning embers that Bob had already introduced. And again, here's another visualization of it. But during the global assessment work of IPCC, and here's a picture of Bob gathering the assessment to a conclusion. We started to think a little bit, can we come up with a different visualization where we not only, or where we're moving, showing the risks to actually visualizing and showing the solution spaces that we actually have to address some of the issues that we are so urgently need to be dealing with. And this is what we came up with. And I'm going to run through a few concrete examples in a bit. But these green shoots sort of look a little bit like this, what you're seeing here on the screen. And, basically, one of the first aspects that we realized when developing these kind of new visualizations is that we actually need to get into a two-dimensional space of showing where we are heading, or we could be heading towards. So the burning embers diagrams, they're actually one-dimensional, right? As it gets warmer, the risk increases, full stop, right? That's easy, so to speak. But solutions can actually be of high effectiveness or of low effectiveness. So therefore, we are actually having this sort of, left to right dimension here on these panels as well. So basically what we're showing here is we're showing, in this particular case, let's say we're increasing our terrestrial or marine protected area coverage by, up to 50% maximum, which is what the so-called nature needs half community is asking for. We're also showing with gray to green color transitions how we could potentially move from a status today, current, which is gray, which is actually not particularly good, to sort of more greener kind of futures. And we're also, basically want to highlight becoming more fuzzy as we're moving away from the current status, and of course the uncertainty of our assessment in this sort of color transition becomes much larger. Protected area effectiveness here, as I said, is given for the effectiveness of the solution, and that relates to where protected areas are, what is the actual level of protection, and how are these managed. So this is the sort of, the concept of those green shoots. But now let me run you through three examples how we can actually apply these to sort of, sustainable development objectives, let me say. First, we want to protect biodiversity, right? So again, we're increasing terrestrial protected area coverage, and we're looking at the impact of different levels of effectiveness. What's the current status? So today's terrestrial protected area, TPA, less than 70% of bird and mammal species, less than 35% of reptiles and amphibians are adequately represented. So this is basically taken from reviewing the existing peer-reviewed literature. Others have shown that of vertebrates threatened with extinctions, only 90% of their range is represented with protected areas. Less than 25% of terrestrial protected areas have actually adequate financial and staff capacity. And they're heavily biased towards areas of limited human use potential where it's cheap to protect, rather than actually protecting areas of high biodiversity value. So, the current level is sort of firmly sitting in a very gray, low zone, low effectiveness, all gray. The level of protection is around about 15 to 16% of the ice-free land surface. Can we do better? right? Can we do better? And then sort of, if you assume that we're just simply increasing the coverage of protected areas, but we're not doing anything in terms of effectiveness, things will actually not improve a lot, right? But there is actually many papers in the literature that would argue if we're not only increasing a protected area, but we are also actually working on placing them in better areas, giving them financial and management support, thinking a little bit about what we're protecting and how we're protecting it. Even with a relatively small increase, let's say to 30%, like a 30% target, we would actually end up in this green area of the shoot. And this is just one example to demonstrate that a little bit. It's possibly quite an abstract kind of paper, but basically what the authors of that study have done, they looked at different connectivities and different priorities for protected areas globally. And they argue if you're moving from the present day, looking for birds, mammals, and amphibians for the moment, what you see A here is sort of basically the present day. In 2014, about 15% of the terrestrial world was protected. And the authors kind of find that 20 or slightly less than 20% of these species groups had actually protection with that protected area network. But what they're actually arguing is if you're sort of, working on, getting a good globally coordinated protected area network together, if you're looking here up to B, just simply increasing the protected area to 17% would actually increase protection of these birds, mammals, and amphibians to 60%. If you actually sort of, look at those dark and light blue line, which is the sort of, the best protected area network, and increase your protected area to something like 30%, which is the target, you could actually even from that particular study assume that up to 80% or nearly 80% of those species could be protected. I personally believe this study is probably a little bit positive, but this is just one example for many other papers in the literature where people convincingly argue that a better placement in money invested wisely in protected area coverage can actually go a long way in protecting biodiversity. But what about the conflict that we actually have on land? And again, Bob sort of, already alluded to that very briefly in a slightly different graph. But the challenge, of course, is of, putting more area under protection, where is our food going to come from, right? About 50% of the sort of habitable land is actually used for agricultural production. We've, of course, also got forests. Forests are used for, timber production and so forth. And how are we going to feed a growing human population that also actually globally shifts towards increasing per capita animal protein consumption and has in rich societies a far too high such consumption anyway? And just to remind ourselves, so these are the current human population trajectories. We are now at around about 8 billion people, and irrespective of which trajectory we're actually going to be on over the next sort of, 1 to 2 decades, the world's population is going to grow, we'll need more food, and we are facing already now an increase in hunger as well. What happens if you are, have a sort of, a thought or a model experiment where you're actually putting 30 or even 50% of the land surface under very strict protection, i.e. you are not allowed to do anything apart from leaving that 30 or 50% for biodiversity, no agriculture allowed. So a very extreme scenario, shall we say. And the first thing that happens, amongst many other things, is that under these sort of scenarios, you will find increases in food prices and enhanced expenditure of people relative to GDP increase. Because you have to produce the same amount of food basically on less area, which is going to be more costly. There might be also less produced, and then sort of, supply and demand that's going to bring the price up. So when you're looking actually the impact that this might have on fewer or additional deaths in human, you'll find sort of, it can go both ways. You actually result in fewer deaths because people eat less red meat. The fraction of overweight and obese people globally and in many world regions would go down. But on the other hand, it also leads to additional deaths because, people have to shift to a less healthy diet, eat less fruit, eat less vegetable, get more underweight. And overall, in this particular experiment, what we're finding that in the world globally, we would have 30 to 50 million deaths in 2060 if we are really protecting 30%. So we're not allowing anything to do in those areas. So you could actually say that very radical measures to protect biodiversity could actually further jeopardize food security and certain health goals, particularly in the most vulnerable regions of the world. And I get back to that in one of my last slides a little bit. Just sort of putting that now in a green shoots perspective, which you're sort of, showing here, basically means that if you're looking at the current status only from a protected area perspective, so today's protected areas on land actually not really limit production, food production a lot, and they also probably provide some benefits to surrounding agricultural regions. So we have put them actually into a broadly beneficial green part of our shoot. Increasing, the food production or the terrestrial area protection to, let's say, 30 or even 50% is going to conflict with food production, as I just showed you in the previous example, particularly if you're looking at high protected area effectiveness, meaning very strict protection. But just out of, for completeness, and actually also, if we were to reduce protected area, which is shown down here, then we actually also get into a gray area. It's not beneficial for the food production because we're reducing habitat for pollinators, we're reducing genetic resources, and we're also protecting our catchments not quite as well. So very sort of, complex green-gray solution space that we have found for this particular shoot. But let's just very briefly also look at climate change mitigation as the sort of, third dimension. And again, looking at how this could look at this sort of, two-dimensional green shoot space. Today's status, again, down here, we assessed as being quite poor because there is actually continued deforestation and degradation, even in protected areas, right? And at current level of effectiveness, i.e. if you're just moving up the axis here, if we are increasing protected area, that would only provide modest climate change mitigation because little protection of carbon stocks and the sinks. A little bit actually also like we have assessed already for the biodiversity kind of shoot. Having said though, if we are sort of moving again towards the effectiveness axis, you actually realize if you're looking at the map up here, which is a map of total carbon storage in natural ecosystems globally, and a map like here, which is one example map for biodiversity hotspots, that quite visually you actually see that many of those dark brown areas where there is a lot of carbon stored are actually also identified as biodiversity hotspots. So these two areas, high biodiversity and high carbon stocks, can actually correspond, not always, but they can respond, most notably so in forests, wetlands, and savanna. So what does it all mean for our 30 by 30 targets, right? So what happens actually if we're looking at 30% protected and putting biodiversity, food production, climate change mitigation side by side? Are there sort of, green areas that we can sort of, identify as where we can go with? And as you can see, it is challenging because in areas with high protected area effectiveness that are dark green here at 30%, we probably run into challenges with food production. But there's additional solution spaces that I'm not talking about here today. So dietary change we have not considered, right? if in rich societies we have less animal protein consumption, then we actually need to produce less, which means that we need less area for food production. And we could also actually have that animal production globally being more equitable. I also haven't looked into what's called other effective area-based conservation. So biodiversity conservation does not end with protected areas. You can actually also do lots of solutions on areas that are not protected. And just to, as a final slide, I've talked about terrestrial protected area here today, but we of course looked also into marine protected areas, which are sort of, equally important when we're looking at those three components of sustainability. And other solutions are currently under development. So we're looking at how does it look for consumption changes, right? How does it look for if we're increasing forest area? How does it look for if we're increasing area under bioenergy crops, which, as you can see already now, is actually not a solution. But this is very much work in progress. And with that, I conclude, and I'm looking very much forward to questions and discussions in the next session. Thanks very much.
Thanks, Alma. That's fantastic. Great. So now is the opportunity for us to have a discussion. I was hoping we could take some questions from people who are dialed into this webinar. So if you would like to ask a question, I can't see any questions at the moment, but if you would like to ask some questions, then that would be great. Somebody's Mohammed, can we open the mic to ask questions? Well, we were going to do it via chat, but if that's possible, I can just read out your question if that works for you. I mean, I have some questions of my own if we want to start with that, but if you have a question, please go ahead and put it in the chat. But while people are doing that, I will kind of, I guess, start with my questions. I guess picking up what Nick was saying about the sort of flat trade-off in finance and the fact that obviously it has huge consequences for sort of equality and environmental outcomes. But we have this sort of disconnect, if you like, between the private financial incentives and the sort of societal goals. How do we deal with that? What's the solution to moving us towards aligning those kind of two aspects? I don't know who wants to take that first, but I guess it's both to Bob and to Nick primarily, maybe slightly less Alma, though very welcome to hear you. Nick, do you want to go first?
Yeah, I don't have all the answers, and for me, I guess the reason I was putting that point was because I think it's the absolutely fundamental one when it comes to this discussion around redesigning the kind of financial system and the incentives that the financial system operates under. Because I think there's historically maybe been too much focus on presenting a kind of different problem, which is the costs associated with doing something with climate change. So anyway, I don't know. The classic response is actually I do have 3 or 4 possible answers here. I mean, the classic answer, first best, if you ask a macroeconomist, is pollution taxes or carbon taxes, right? But we know that that's been really difficult to implement at a global level because of this issue of free riding. So, we can introduce carbon taxes in one country, but you potentially just ship industry off somewhere else, and that might be a good thing if you want to ship the pollution somewhere else, but it's also obviously not a good thing from the perspective of jobs and in particular industrial areas. I guess there's 2 or 3 alternatives, I guess what I think of as second best, that people are exploring, which I think are interesting. The one is the classic one, which the environmentalists, ecological economists have always pushed, is this idea of more collective ownership at a small scale. So this idea, I don't know if you've heard of Ostram's sort of 8 rules for managing the commons, but the idea that when you have something that is managed by a community it's often managed extremely well. So commons don't have to be badly managed. They can potentially be managed well. Now, the issue I think I have with that one is that it probably works better for nature-based solutions than it does climate, because climate's genuinely a global problem. So I think it's, people tend to value the nature around them more than they would necessarily the climate. Another one would be one that's talked about all the time in finance is sort of green-brown capital differential. So the idea that you charge more in the cost of capital for brown activities, so things like extracting fossil fuels, than you would do in green activities, investing in things like nature conservation, restoration, and the idea that you can tip capital, the cost of capital. Now, there are some downsides with that one. The one that I think is most topical is probably the idea of tax credits instead of taxes. So at the moment, over the last year, this has kind of come out of the US. There's been a big shift towards using tax credits to allow for more investment in renewables. So what's known as the Inflation Reduction Act. And the thing that's really interesting about that is it potentially gets over the free riding issue you have with fossil fuel taxes. So because you almost start a race, who's going to be greenest, and the jobs come to the places which are offering the biggest credits. Now, the big downside of that one, though, is that you potentially don't encourage conservation, which is perhaps the most important kind of reaction or response to too much pollution. So you potentially, when you look at what happens in the US, it's not obvious there will be a lot of additional, move to more efficient fuel cars or more fuel efficient housing. So, but those are some of the ideas. Now, Robert, perhaps you could jump in here, and there's plenty of stuff that I've missed.
No, Peter, I mean, you've quite clearly asked the right question. I mean, it's really easy, as we've said in all recent international assessments, we need to reduce perverse subsidies. We need to internalize externalities. I mean, IMF would argue that between the direct subsidies and the failure to internalize externalities in fossil fuels is $5 trillion a year. A bit less than $1 trillion a year in direct subsidies and over $4 trillion a year in failing on externalities, as Nick also mentioned. So the question is, and that's what we've obviously got to try and find a solution to in GO7, we know what to do. The challenge now is how to do it. How can you make reducing subsidies and incorporating externalities in the prices of goods and services politically and socially acceptable? Because as soon as you do that, the price of goods and services goes up, whether it's food, whether it's energy. And therefore the question is, while the middle class and upper middle class can afford more money for food and energy, poor people and working class people often can't. So the question is, can governments put in social safety nets to protect the poor? And so I think the question you've asked is at the heart of why we haven't achieved anything or not achieved much in the last 5, 10, 20, 30 years when we've known we've got these problems. So we have to find a way to deal with the vested interests who love the perverse economic system of today, love the failure to internalize externalities. So that's why when I talked, I focus, and we know we're going to do this in GO7, focus on energy and food systems. They're the ones we have to get right. But in my opinion, unless we get the economics and the financing right, we can't ever succeed. I would argue this is the key to success, is the transformation of these two systems in the ways that politicians will run with it, society will accept it, and the private sector and the finance institutions can go with it. So this, to me, is the whole key to transforming to a sustainable future.
Yeah, but very challenging. Alma, do you want to contribute to this, or you?
No, I'm not a finance specialist, but actually I've been pondering actually while Rob and Nick were speaking, also a little bit about, you know, some discussions I've had recently with various people, and also a few papers that came out along the lines, which is the sort of offsetting, you know, aspect of the entire system, right? And certainly, you know, the offsetting that's currently being done in sort of land-based sort of, you know, solutions, i.e., you know, I'm going to give someone to not chop down a piece of forest. I mean, that's all sounds wonderful, but all it actually does, in the best case, if it actually works, it actually doesn't work, right? To begin with, it doesn't work. But if it actually were to work, you know, all it does is we're actually reducing any additional emissions from chopping down forests, but we're not actually going to remove those emissions. And everywhere, you know, I'm going to these days, I'm buying carbon neutral products, you know, and they're not carbon neutral, right? It's just giving money to someone to protect forests. It's not going to change my emissions. And I get actually really upset these days when I drive past, I don't know, you know, climate neutral fuel stations, right? And I just really would like to actually hear Nick's views about what the finance sector is actually, you know, thinking, you know, with these particular measures.
Yes, because it's voluntary carbon markets.
The voluntary carbon market, exactly.
Being the topic that's being discussed. Yeah, Nick, do you want to respond to that?
I can try to. Again, I don't have the answers. But I think it's a really central problem. So when I showed that stairway to net zero, I guess what's interesting in the first couple of steps there, the first 5-year steps, is a lot of what is being assumed in those pathways is that we will stop degrading land and we will stop land-based emissions. And you know, it's about a quarter of the contribution in those first two steps. So there's 3/4 is coming from cutting fossil fuel. The other quarter is coming from us dealing with land use change. And one of the reasons why that comes in early on is because it's considered cost effective. It should be, in pure economic terms, it should be a pretty low cost thing to do compared to some of the other things, like, say, for example, getting rid of coal and steel manufacturing, you know, the high cost things you have to do later on in the stairway. So, and then the challenge, and the one where I don't know the answer, is then, so how do you finance restoration, natural restoration, you know? Because it's the opposite. You're not taxing a bad, you're trying to encourage people to finance a good. And the obvious way, you know, would be, you know, the interesting thing about the carbon offset markets is it seems like that's a way, what they're trying to do is kind of financialize or incentivize people to do that. But it hasn't worked well. And, you know, there's clearly, it's not, and I think it's not scaled because it's not worked well. So everybody knows those, you know, we are net zero now. Everybody knows those claims are not credible. So, and I think that actually leads to a problem with the market not scaling. The market's much smaller than it should be, and much, you know, there's much less money going in to restoration than there should be if you just look at the size of those voluntary markets. So I don't know, and then it gets even more complicated when you start looking at biodiversity offsets, because there is some market, obviously, in terms of permitted development. So there's a way of measuring the value, and, you know, you have to go off-site if you're going to damage biodiversity. But there's certainly no big push to, you know, try to grow that financially. So I don't know. Yeah, but I think it's critical, because you have to try, you know, when you're looking at these 30 by 30 or half world commitments, you have to work out how you're going to get money flowing in that direction as well. You know, not just cutting off the subsidies for fossil fuels, but actually money flowing to the public goods, you know?
Bob, do you want to say anything about voluntary carbon or biodiversity markets? No. Okay, fine. Great. So, well, since we have one question on the chat, I better ask it, which is basically, we haven't talked enough about water. In very summary, I think, I don't know if anybody wants to address the point.
Well, I could just quickly start before I think Bob will also want to say something. I mean, if we if we manage to protect our existing ecosystems better, and that again, that's not only terrestrial systems, but also the oceans, of course, as well. If we manage to restore those ecosystems, that is typically also very, very beneficial for water regulation, both in terms of flood protection, in terms of erosion control, in terms of water quality as well. So I can see some clear win-wins actually in that respect.
Yep.
Just another comment on water. Yeah, if we can protect our ecosystems, it can help. But it's another issue of what water pricing policies. If you don't put a price on water, people waste it. And so I think but it's a very sensitive political issue. But once again, governments could design policies that for the first so many litres per day per capita, it's free of charge. Then as a household or an industry increases the use of water, you start to charge accordingly. And so you have a price curve that starts at zero, so everybody gets a certain amount of clean water. And then as a person increases their use, they start to pay for it. But it is politically sensitive. But to be honest, when we don't price things appropriately, whether it's water, whether it's energy, whether it's food, we waste. Food waste. 35% of all food that's produced is wasted. And it's because we don't price food correctly. But the question is, again, how do you protect the poor?
Yep. Okay, great. So if anybody has any other questions, there's no limit.
I've got a question for Elmer, and that is,
great.
Elmer, in all your slides, and you looked at the efficiency, how does one build in climate resilience to protected areas? Clearly, climate is going to change. And so and I think we have to assume personally 2.5 to 3 degrees Celsius over the next 50 to 100 years. And so as we design these protected areas, is there any appetite, or are people really thinking through carefully how you design these systems to be climate resilient?
I think the two questions that you just asked, I start with the first one. So with the sort of current design and assessment that went into the shoots as they stand, they are in a sense not really made for explicit future climate change scenarios. They're sort of very much thought experiment about changing the level of protection, but otherwise sort of very much background, sort of everything else staying constant. But it clearly, doing something similar for, very explicit, future climate change scenarios is basically an additional exercise that we haven't done yet, but everyone is sort of very willing to actually sort of, engage with that similar kind of, work as well. It's all, published and everything. And it's clearly one of the next steps that we need to address. Are actually people thinking carefully about designing, protected areas in view of climate change? I can't speak for the entire world, but I do know that certainly within Europe, there has been a discussion about that, sort of, around what we call the Natura 2000 sort of networks and so forth. And the managers there are extremely aware of the issues that arise with climate change, and, and the whole issue about, making sure that protected areas are much better connected, also in view of climate change, is certainly on the agenda of the people who are doing the sort of, on the ground management of those systems. Whether or not the politicians are going to support them by putting adequate finances into it, that is, of course, then a question that is still very open, and my suspicion is there is not enough money.
Okay, to change tack a little bit, I think we've heard that there's, somewhat, the financial sector are doing analysis, and the academic sphere are doing their own research, but there's not a huge amount of crossover between the two. There's a lot less than perhaps there should be. Do you think that's true? And if you do think it's true, what can we do to improve that sort of cross fertilization between the two and have more benefit from each other's insights, I suppose. Nick, do you want to start?
I can do it again. Yeah, I mean, it's interesting because I've just completed a master, and it was a part-time master. So I spent the last 3 or 4 years, I guess, talking to people that work in the academic space. You know, it was ecological economics, so sort of people in the sustainability space. I would say, yeah, when I talked to them about what was going on in finance, there wasn't a huge awareness. You know, the timeline I gave you there. You know, if I talk about what everybody in finance is talking about, most of those points in the timeline were just they didn't know much about, you know, these things. And sometimes, you know, I think people are maybe a bit scared. You know, they sort of think they don't understand finance, so therefore they are a bit nervous to kind of talk about things. But then everybody does understand that these, you know, all the stuff you're talking about needs to be financed, needs to be funded. So yeah, on the finance side, I guess it's kind of a bit the opposite. There's a kind of echo chamber thing going on there where it's not obvious that people think hard enough about the broader issues. So I think there's kind of two different groups that maybe don't interact enough. How can I bring them together more? I don't know, how could we bring them together more? Well, obviously events like this, but I don't know.
Good answer.
Do Robert or Almut have any ideas on that one? Second half of the question.
Thanks, Nick.
But are things moving in the right direction? So, for example, the World Economic Forum and the World Business Council on Sustainable Development do seem to be taking some of these issues seriously. Every year, the World Economic Forum that meets in Davos, as we know, in late January, they come up with their top 10 risks to the future of industry. And in the last 3, 4, 5 years, 4, if not 5, of the top risks are all environmental. Climate's always been there. Biodiversity's there. In the last 2 years, they put pandemics there, obviously, after COVID-19. But the year before COVID came, the top 5 were all environmental risks. It was climate change, pollution, loss of biodiversity, etc. So if indeed there is a true dialogue with the leaders of industry, both the finance sector and other productive sectors, that surely must be at least going in the right direction. I mean, I probably have more confidence the private sector will do the right things with bit push from government than some governments, to be quite candid. You only have to look at how governments have responded to the COVID crisis and the Ukraine war, of trying to keep energy cheap, trying to get food cheap, all the things that are working in the wrong direction for a sustainable food and energy system. Why? They want to get re-elected. Biden will do anything to get re-elected, and so effectively they're making sure that energy prices are low, but they're not moving it in the direction that will meet the goals of the Paris Agreement, etc. So, you know, to be quite honest, the challenge is we have a public, and I fully understand it, that wants cheap food, wants cheap energy, and governments and the private sector try to satisfy that. So we're all to blame. We as individuals want things that are cheap, government try and supply it, private sector try and supply it. So is government causing the problem, or the private sector, or us? It's us collectively, and we have to have a vision collectively of what future do we all want for our children and grandchildren that's equitable between developed and developing countries. It's a monstrous challenge in front of us. It's doable, but there has to be trust. And at the moment, there's no trust among governments. There's a lack of trust between governments and the private sector. And the public doesn't trust government either, or the public sector. So we've really got a trust issue in front of us.
Can I just add to this? I mean, I think there's also one additional point when it comes to governments don't act because they want to be re-elected, but also there's plenty of governments out there that actually don't get elected, right? And they're not acting the right. So the benign good king or queen they also don't exist, unfortunately, which is a great shame. But maybe coming back also to the sort of more academic perspective, I also wonder, in addition to the points that have been made, whether institutions like the IPCC or IPBES or other big assessment sort of things should actually reach out more specifically to the finance sector. That hasn't really been done. I mean, there is always economy in there, but not really talking to people who are actually dishing out the money, right? And I think there's plenty of scope to have the dialogue in those assessments much more stringently looking at finances.
I couldn't agree more. The trouble is, I mean, when I chaired IPC a long while ago, we kept trying to reach out to the private sector, and they kept on telling us they could not release their best people to be a convening lead author 20% of their time. But you're absolutely right. I think all of these assessments, IPCC, IPBES, GEO, the IRP, they must all try and encourage the private sector to play a much more dominant role. They understand the market. I mean, academics, yes, can talk about the market, but boy, the people in the private sector, but also we need actual people that work on policy in governments, not to bring forward their own individual government policy, but understand how policies are made, implemented, the challenges, the barriers. So I would argue that in all of these international sectors, having more people from both the private, including financial sector, and from government, good policy would actually improve all of these assessments very much.
Yeah, well, I'm sure Nick would be a fantastic lead author on one of these assessments. So I'll leave that with you.
Quite a lot of work. I'm sure Albert can say something about that.
Anyway, I'm just joking. Well, not half joking.
Yes, only yes.
So we have one question in the chat from Neil Harris, who's asking about speed of funding and multidisciplinarity in projects. And that there's a lot of progress that's made during these assessments when bringing people together, which is, of course, I think something we would all agree with. Yeah, I don't know if you want to address that. How do we get more rapid funding and kind of bigger interdisciplinary projects? I suppose in a European context, obviously, or the UK European context, it's great news. We're back in Horizon. So that's a little bit parochial, but important nonetheless.
My only comment is, I mean, when I worked in the British government and the US government at funding, what I found is funding agencies are very parochial. Even the research councils, they may be changing in England, so I might be out of date. But the Social Science Council wanted more social science than natural resources, etc., etc. I recognise there's a real challenge of getting funding for multidisciplinary, transdisciplinary research in the United Kingdom. I also have noted similar things in the USA. But also what I found was two other challenges to multidisciplinarity. Many journals are very discipline specific. I know a few of my colleagues that do write papers that are very multidisciplinary, can't always find an easy way to get them accepted. So are the journals open to multidisciplinary research? And then, of course, university departments. Some universities encourage multidisciplinarity. Others are still very stovepiped in the discipline. So I think there are funding issues. There's maybe issues with journals and university departments. Now, I might be out of date, to be honest. I mean, I left the British government 10 years ago now. Things may have changed drastically in the last 10 years, but there seems to be a couple of challenges for making sure we do good multi-interdisciplinary, transdisciplinary research.
Yeah, I'm not sure if I'm allowed to answer the question, but I will anyway. You know, I think very often the calls are good and have a lot of interdisciplinarity in the call text, but the review panels can be more challenging and can be more sectorally siloed. Anyway, maybe a last question. I wanted to ask, because I'm sure it'll get a reaction from Bob at least, what your opinion of 1.5 is and whether you think it's helpful or not. I mean, I think we all know that you don't think it's achievable, but do you think it's helpful to have it there at all?
Yes, I think we need to aim as close as we can to 1.5 or 2. I truly don't believe we'll even manage to do 2 degrees Celsius. There's nothing in the political will that I see on the pledges that's going to get us there. Should we have a target? Yes. We've got to keep aiming to get as close to that target as possible. But we have to be honest with the public that we're not on the pathway to 1.5 or 2. We must be honest with ourselves and not fool ourselves. And that's why I say net zero, absolutely needed it for 2050, but it's allowed every politician to talk about net zero. None of the current politicians will be a politician in 2050. We can't hold them accountable. What we must push for is what will we do between now and 2030? And these politicians, we can hold accountable for what they do in the next 2 to 8 years.
Alma, what's your view in 1.5 degrees?
Yeah, I sort of would echo that. I mean, I think actually if you read the Working Group 1 report from the IPCC, it actually clearly says we are not going to reach 1.5, or we're going to overshoot 1.5 degrees, right? So it is clearly not achievable, and we're not on a trajectory. And yes, I mean, should we just throw it out? I think that also would be probably counterproductive. I just really wonder in terms of, and I don't want to sound cynical here at all. It's actually more sad in a sense. But just looking at what happened this year, right? I mean, we had 1.2 degrees global mean warming. You know, we've got wildfires from Canada that released 0.5 gigaton of carbon into the atmosphere, right? We've got 20,000 people killed in a bloody flood event, right? I don't know how many people died in Greece. It's shocking, it's sad, but you know, I got reminded of the old saying, you know, the climate is a very dangerous beast, and we are poking it with a very sharp stick. And how many more tens of thousands of people will we actually have to see killed in the next 5 years? And is that really necessary as a wake-up call to us? If that's the case, that's really sad. But I don't know. I mean, it seems like that is actually necessary for people to act, right? And I might sound very pessimistic about the human race here, but I am actually quite pessimistic about us, you know, calling us intelligent, right? Sorry.
Yeah. Okay. Yes. I mean, I yeah. Nick, I might leave you the final word if that's okay.
On 1.5.
on anything you like.
Yeah, I mean, I agree. It does look increasingly unlikely that, you know, we're going to meet it. My guess would be early 2030s. You know, I think as you move, I guess, what do you have to focus on as you move beyond that? I think focusing on things like adaptation, resilience become really important. And one of the downsides of having that 1.5 degrees focus is that we maybe haven't talked enough about that, or you get dismissed as being a denier or a lukewarmer, you know. But when you start thinking about adaptation and resilience, and I think those things will become more and more important.
Great. Thanks. Right, I think we will call it a day there. Thank you for your time. That was really great. Hopefully it was enjoyable to people who are listening live and people who listen to the recording. Thank you very much.
Thanks, Peter, for organizing.
No problem. Bye.